Okay everyone, so now we are learning the first type of array, which is the 1D array or called one dimension array. In that we are learning that how to declare a 1D array. So first of all, we should be having the data type, then array name, and then we will provide the bracket in which we will provide the array size. So here we are assuming that the data type is integer. So we are writing here int, that means it is the integer data type. Then the array name, we are assuming that this is a. In the bracket we are providing the size, which is, let's say, 5. So here we are declaring the array, which is int a5, then afterward semicolon. So in the memory there will be 5 blocks will be reserved. Here the name of array is a. Then afterward, we are having these 5 blocks. So 1, 2, 3, 4, 5. These 5 blocks are reserved. So A is the name of array, 5 is the size. We are assuming that here we are having the integer which is of 2 bytes. So if the first block start with the address 300, then the next will be +2, 302, again +2, 304, again +2, 306, again +2, that is 308. We know that array can be accessed using the index because it is a sequential memory allocation. So here 0, 1, 2, 3 and 4. So this is how we can declare the array. Similarly, if we want to declare an array of float type, so simply we will write float. Then afterward we will be writing name of array. Let us suppose that B is the name and again 5 is the size. So this is how we can declare a float array, or we can declare a character array by simply saying char and then afterwards C. Then similarly, let's say 3. So it is containing the 3 blocks, means 3 characters can come here. So this is how we can declare the array. Now we are learning that how to initialize the array. Let us assume that I have declared one array. So I am writing here int, then afterward a5. So we know that is the declaration. So declaration we have already done. If I want that there should be the elements inside this array, that is called initialization, means providing its value. So I will provide equal to curly bracket start. In that I am going to provide the 5 values. Let's say the first value is 10, then 20, 30, 40 and 50. So these are the 5 values. Now afterward semicolon. So there, if we have declared the array, inside that we can initialize or provide the values. So here we have the first value, which is 10. So the 0th index will be having the value 10, then afterward 20, then 30, then 40 and then 50. So here we have provided the values to the array. This is called initialization. Here we are understanding one more thing. Let's say if I am writing int a, then brackets are empty. Then afterward I am writing, let's say 10, 20, 30, 40 and 50. That is perfectly valid. Here we have not given the size of array. So here the size is empty, but we have provided the initialization. So if you are going to initialize the array while declaration, just like I am providing 10, 20, 30, 40 and 50. So these are the 5 values. So at that time size is not required. So if you are not providing the size, automatically compiler will allocate that this is the A5, because we have given the 5 elements for initialization. So compiler automatically provide the size as 5. So that is perfect, no problem. Now we are taking one more example here. Let us suppose that I am writing int a. Here we are having 3. Now afterward I am saying, let's say 0, 0, 0. That means declare an array whose size is 3. So we are having an array A whose size is 3. That means 3 elements can be coming here. Let's say the address is starting with 300. So next will be 302 because integer is of 2 byte. We are assuming. Then afterward 304. So here these are the 3 memories. Then we know that they can be accessed during the index values 0, 1 and 2. Inside that, we are going to provide 0, then 0, then 0. So all the 3 zeros will be coming here. This is the normal initialization. But let us suppose I am modifying here. If I am simply writing here int a3, then afterward equal to, in the bracket I am providing only 1 0. What is going to happen in that case? Similarly, I am taking one more example here. Let us suppose that I am writing int a, and let us suppose that this is a3. Now afterward I am, let's say, saying 7 comma 3, then bracket close. What is going to happen? I am taking the second example first. So here we are having is the int a3. That means there is an array which is having the 3 element space. So here we have initialized first element with 7, then second element with 3. We have not given the next element. So compiler automatically provides 0 here. So that is also valid initialization. Similarly, if we talk about the first example, which is int a3. So here we will be having an array who is having 3 element space. Here we are initializing only one element as 0. So here one element is 0. Rest will be automatically 0. So that will be given by the compiler. So here in second example, the 0 was added by the compiler automatically because user has not given the element. In the first example, 2 zeros are added by the compiler because user has not given. So that means these two things are exactly same, where we have given all 0 or where we have given a single 0. If you are going to provide all 0 in an array, you can simply provide 1 0. So automatically all will be 0 because other zeros will be provided by the compiler itself. Now we are taking one more example here. Let us suppose that we are writing int a3. Then afterward we are providing, let's say, values which are 10, 20, 30, 40. Here array is having 3 space, but we are providing the 4 elements. How it will work? So here we are having is int a3. That means we are having an array who is having 3 element space. Here compiler will see that the first element can be 10. So I can store 10 here at 0. Then 20 I can store at the 1. Then 30 I can store at 2. Then afterward one more element is extra. So that is wrong. Compiler will show the error. So that line will not execute because compiler will show the error. This is logically incorrect because we are providing the size as 3 and we are providing the 4 elements. So that is not possible. This is the invalid initialization. So here during the initialization, if you are providing all the elements, that is perfectly fine. If you are not providing the size, again it is fine. If you are providing all 0, it is fine. If you are only providing 1 0, automatically all 0 will be provided. Then afterward, if you are giving 2 elements, then rest of the elements will be 0 automatically by the compiler. So these are all valid initialization. But if you are providing extra element, that will be invalid initialization. Here we should note that the first part where we are saying int a5, this is called declaration. And after declaring the array, we are providing its value. So this is the second part. This is called initialization. Whenever we are using the data type as integer while declaring the array, so this is called integer array. Now we are going to take the example of a C program. With the help of that, we will understand that how to declare and initialize the 1D array. So now we are learning the integer array in one dimension. So first of all, in the program, we have given a command which is 1D integer array. Then we are taking the header file #include stdio.h, which is for printf and scanf functions. Then void main, which is the driving function. Then we are saying is int a3. We know that this is called declaration of array. So one array is declared inside the memory, and here we are having is the 3 blocks because the size is 3. So we are assuming that the size start with the base, that is 300. So base address is 300. We are assuming that integer is of 2 bytes. So every block contain 2 bytes. So next block will be 302. The next will be 304. Array can be accessed with the index values. So it is having the index value 0, 1 and 2. Then afterward we are saying equal to 10, 20, 30. So this is called initialization of array. So array is initialized with the value. The first value is 10. So here at 0th we are having 10, then 20. So first index 20, then 30. So all the three elements are initialized. Afterward we are having is I. So one variable I is declared inside the memory, and that I variable may be having some address, let's say 501. Afterward we are having for I equal to 0. So inside the I we are having the value which is 0. Hypothetically we can say that I is at 0. And afterward I less than 3. So 0 less than 3, the condition is true. And further it will come down. So here printf means print on the screen %d for the integer value. So here %d will take the value from ai. ai, we know that the value of I is 0. So a0, what is the a0? We know that a0, that is 10. So the 10 will be printed. Then afterward /t, so one tab space will be given. It is a loop, so it will go back. Then afterward we are having is I++. So the value of I will be incrementing, that is 1. Then afterward again it is checking the condition that I less than 3. So 1 less than 3 is perfect, true. Again coming down, printing on the screen, %d will take the value from ai. And ai is now a1 because the value of I is 1. So here a1, we know that a1 is 20. So 20 will be printed. Then afterwards /t, so one tab space will be given. It is a loop, it will be going back. Then I++, so the value of I will be incremented, that will be 2. Again checking the condition, is I less than 3? 2 less than 3, perfect, yes. Again coming down, printing on the screen, %d will take the value from ai, and we know that I is 2. So this 2 will be taken, and the value of a2, so a2, the value is 30. So this 30 value will be printed. Then again tab space, so it is a loop, it will go back. Then I++, so the value of I will be now 3. Again checking the condition, I less than 3, so 3 less than 3, false. Condition is false, so loop will come out. So here we are having the output on the screen, which is 10, 20 and 30. So this is the output will be on the screen. So this is how we can take the 1D integer array. So here we have learned that first of all the declaration means we have declared array by saying int. This is the data type, then the name of array, then afterwards size. Then we have done with the initialization. So here the first part was the declaration. So here we have declared the array. Then afterward is the initialization. So here if we have given the array size 5, so we can provide the 5 elements by saying 10, 20, 30, 40 and 50. Then there is a second way also. We cannot provide the size if we are providing all the values. So here the size is not given and we are giving the value just like 10, 20, 30, 40, 50. So that is also perfectly fine. So these two ways are perfectly fine. If we are providing the size as 3 and we are providing the 3 zeros, so all the elements will be zeros, that is perfectly fine. Or if you are providing the size as 3 and giving 1 0, then all the remaining elements will be provided 0 by default by the compiler. So that is also fine. In case of character array, the remaining values will be null, which is the /0. Then afterward, if we are providing the size 3 and here we are giving the 7 and 3, so the remaining values will be 0 by default. So you understand that if the array size is let's say 5 and you are giving the 3 elements only, the rest 2 elements will be 0 by default. So this is also correct. But let us suppose that the size of array is 3 and you are providing let's say 4 elements. So this is logically incorrect. So this is not the proper initialization. In all the cases, we have learned that the values are given to the array when we are doing the coding. But what if I want the input from the user? In that case, how it will work? So now we are taking the example for that. Let us suppose that we are going to take array declaration. So first of all, we are providing the data type, that is int. Now afterward, we are providing the name of array, let's say A. And here I am providing, let's say, 4 as the size. So this is the array declaration. That means the array will be declared with the 4 blocks. So here the name of array is A, and let us suppose that they are having some memory addresses at the space of 2, because the integer is having 2 bytes. So starting from 300, that will be 302, 304 and 306. Array can be accessed using the index value because of the sequential memory allocation. So here I am providing the index value, that is 0, 1, 2 and 3. So this is the range. Now we are discussing that what is the way of initialization if you want the input from the user. The first way we already know, that provide the curly bracket, inside that provide the values. Or we can provide the value by their index location. So here understand that here A0, so you can provide the value by saying, let's say A0 is equal to 10. So that means at A0, 10 will be stored. Then further you are saying A1. So we know that A1, that means A1. So this block is having value 20. So that means 20 will be stored here. Then you can say A2. So here we can provide A2, so signifying a block where we are providing the value, let's say 30. So here value will be 30. Then A3, so here we are representing the last block. So we can say that A3, that will be having the value which is 40. So here the value is 40. So this is the second way by which we can initialize the array. Now let us suppose that there are 50 elements. So do I have to write this 50 times? No, we can apply the for loop here. So here this is the second way of initializing the array. But let us assume that the values 10, 20, 30, 40, I want to take it from the user. So we know that we have to take the scanf statement. So here I am writing, let's say, scanf. Scanf means taking the input from the user. Then what are the type of value? That is integer. So here I am providing %d. Now comma, add the address. What is the address? You understand that every time we are saying A0, A1, A2, A3. Can I take it as a AI? Yes, I can take it and I can run a loop. So here simply we are saying AI. Now this I we can place inside a loop. So here we are taking a for loop. We know that first of all I will be initialized. We know that the first value is 0. So we are taking the 0 here. Then after what is the last value? So that will make the condition, that is 3 here. So based upon the 3 we are making the condition. You can say that I less than 4 or maybe I less than equal to 3. Totally up to you. So here I am mentioning that I less than 4. Then afterward I plus plus. So here this line we are putting inside the for loop and we are ready with the array input. So by this method we can take the input from the user and all the values will be going to the array. So now we are going to take one example. With the help of we will understand that how to take the values from the user. So here we are saying first of all is a comment 1D integer array. So we are learning right now the integer array. Then hash include stdio.h, which is for printf and scanf function. Then void main. Void means no return type. Main is a driving function. Now inside that we are having is int a3. That means we are going to declare an array of integer type. So in the memory we have reserved the 3 blocks. The name of array is A. And here let's say the address is starting with 300 and integer consumed 2 bytes. So 302 and 304. Array have the index values. So here 0, 1, 2, these are the index values. Afterward, we are having is I. So one variable I is declared. So inside the memory, we have reserved one block. The name is I. Let's say the address is 701. Afterward, we are saying printf means printing on the screen, enter 3 values. So here in the user screen, we are having a message that enter 3 values. Afterward, we are having is a for loop. In the for loop, I is 0. So I will start with 0. So hypothetically, we are assuming that I is there on 0. Then afterward, I less than 3. So here 0 less than 3. Perfect, fine. Coming inside, scanf, taking the input from the user, %d for the integer value. So here cursor is waiting and user has entered the first value, which is 10. So that 10 is taken and stored at the address of AI. We know that the value of I is 0, so A0. That means this A0 representing the block. So here 10 is stored. It is a loop. It will go back. So here afterward I plus plus, the value of I is incremented, that is 1. After that, again checking the condition, I less than 3, so 1 less than 3, perfectly fine. It will come inside, again asking a value from the user. So user has entered the value, which is 20. So %d for the integer value, it is storing at the address of AI, and AI, A1, because the value of I is 1. So here 20 is stored. Again it is a loop, it will go back, then I plus plus, the value of I is incremented, which is 2. Again checking the condition, I less than 3. So here 2 is less than 3. Perfect. Again coming inside, asking the value from the user. You has given the value, which is 30. So here that integer value is stored at the address of AI. So A2. Here the value is stored, that is 30. It is a loop. It will go back. Again I plus plus. So the value of I will be 3. Again checking the condition that I less than 3. So here 3 less than 3 false. Condition false. So here loop will come out. So we can see that the for loop we have provided for taking the input from the user and storing into the array. So our array is perfectly initialized. So by this for loop we have initialized the array. Now is the time to show the values to the user. So printf means printing on the screen values. So here we can see that values, it is on the screen. Again for I equal to 0, so I is again starting from 0. I less than 3, the condition is still, that is less than 3. So now it is true, it will come down, printing on the screen %d integer value. From where it will take? It will take from AI. So AI, the value of I is 0 right now. So A0, we know that the value is 10. So that 10 is printed. So we can see that 10 is printed. Then one tab space. So a tab space is given. Again it is a loop. It will go back, incrementing the I. The value of I will be 1. Checking the condition, 1 less than 3. Perfect. Again coming down. Again printing. %d will take the value from AI. And I value is 1. So A1 is 20. That 20 value is displayed on the screen. Then afterward is a tab space. So one tab space is given. It is a loop. It will go back. So the value of I will be incremented. That is I plus plus, which is 2. Afterward, we are having is the condition check. So I less than 3. So 2 less than 3, perfectly fine. Coming inside, printing on the screen, %d for the integer value. So here integer value is taking from AI. So AI means A2 and A2 is 30. So that 30 is given on the user screen. Then afterward a tab space is given. So again it is going back. Then I plus plus. So here the value of I will be 3. Checking the condition, I less than 3. So 3 less than 3. Condition is false. It will come out. So the next for loop we have applied for displaying the values to the user. So here we have declared the array. Then afterward initialize the array and display the array to the user. So here we have learned that first of all we are going to declare the array. Then afterward there are various ways of initialization. Just like if we are having the A4, so we can say that int A4, it will be equal to, now in the curly bracket we are providing certain value. Let's say we are saying 10, 20, 30, 40. So these value we are providing into the curly bracket. So this is the first option by which we can initialize. Or there is another option that we can go to the individual indexes. So here this is the second option by which we can initialize the array. So by going on the specific index, just like we are saying A0 equal to 10, A1 is equal to 20, A2 is equal to 30, then A3 is equal to 40. So by this we are going to initialize the array. So this 1 and 2 ways, these are called the compile time initialization. This 1 and 2 are called the compile time initialization. The reason is that we are providing the value when we are doing the coding. So when we are providing the array, at the time we are providing that 10, 20, 30 and 40 are the values of array, or maybe in the second case again we are providing 10, 20, 30 and 40 are the values. So while we are doing the coding, means at the compilation time, compiler knows that what are the value of array. So this is called compile time initialization. There we have discussed the third method also. In the third method of initialization, we are asking the values from the user. So here we are running the loop from 0 to 4, and here we have provided the scanf statement where we are taking the values at the address of array. So one by one we are taking all the elements by the user at runtime, because the program is running and user is providing the value. That's why this option number 3, this is the runtime initialization. So these are the ways by which we can initialize the array. If we are doing at the programming time, it is called compile time. And if we are taking from the user at runtime, so that is called the runtime initialization. So that is all about the array.